This is 2024, the deferred paper, paper 2, question 3. So question 3 starts off with construction. And we're asked basically, we're given just this circle really and the centre P and a point on the circle Q, and we're asked to construct a tangent. So I've done here already, so I'll just walk through it and show the steps. When you're asked to draw a tangent to a circle, here's the first thing you do. You draw a line from the centre to the point that they gave you on the circle, which is Q in this case. You join those together and you extend it on a little bit beyond Q. And then what you do is you put the point of your compass on Q and you open out an arc. And you mark off the arc, the same arc on both sides, equal distance from Q on either side on the new line that you've constructed. And then what you do is you bisect this little line segment here between the two arcs. And bisecting involves opening out your compass to more than half, drawing a little arc above and a little arc below, and doing the exact same thing on the other side, leaving the same arc, the same radius. So you draw an arc up here, an arc up here, and you join those two with the intersection points. You join them, and you'll find if you've done it correctly, it will go through Q and it will be perpendicular. Therefore, it's the tangent to the circle at Q. Moving on to part B, another circle has a circumference of 30. So that's what I call a trigger word, the word circumference. You should be alert for these trigger words at all times in exams. And circumference means you go to your table, you get, if you don't know it in your head, the formula for a circumference or the length of a circle is 2 pi r. 2 pi r is 30 in this case, we're told the answer. So we can rearrange to get r. Divide across by 2 pi and you get r is 15 over pi. And finally the area, there's another trigger word. Area is pi r squared, it's also on the tables. So put in this for r and work it out. 225 over pi squared, a pi cancels and you get 225 over pi, and we have to leave it like that. When it says in terms of pi, that means leave the pi in your answer, do not put the pi into the calculator. Okay. Part C. O is the centre of a different circle. A and B are points on the circle. Okay, so just to talk through what's happening here. We were given, so the blue again is my markings, the black is the original question. So you see here there was a centre of a circle, this is the circle here, and there's 4 points on the circle given, A, B, E and D. There's a point C over here. If you project basically that chord, it goes into C, and this line projects to C as well. Now we're told certain things, again make the diagram sweat is the tip here, we've done this in other questions, and fill in any hidden radius, that's my recommendation. So my instinct for these questions again, and it should be yours after a bit of practice, is whenever you see a radius, fill it in. I mean, from 0 to A is clearly a radius, so mark it, R. Here's a radius clearly from O to B, mark it, R. And straight away you see something. That's now an isosceles triangle. So you wouldn't see that if you hadn't followed this tip, fill in any hidden radius. Which means those two angles are the same. That's a theorem from junior cycle. If those two sides are the same, well, those two angles are the same. And we'll come back to those later. Something else we know, of course, is we're actually told in the question that BC is equal to the radius. We're actually told as well that this is also the radius, BC. So now we have something else going on. We now know that this and this radius, that's now isosceles also. So that's where I start actually my work here. I start with this isosceles triangle right here, and I say, okay, well, if those two sides are R, well, those two angles are the same. I just call them X. Now, what does that mean about this? So the whole point of the question is to find theta over here. I just call the theta, call it whatever you like. We're looking for that. So it says the angle AOE, which I just call theta. Right, so let's work through this. That's X and that's X, which means the three angles must be 180 altogether because it's a triangle. So the remaining angle is 180 minus those two angles. So it's 180 minus 2x. Now, also, you might notice that 180 minus 2x is on a straight line, which is 180 altogether. So if you think about that, if it's 180 altogether and that's 180 minus 2x, that must be 2x. Because 2x and minus 2x cancel, and you just get 180. Or if you want an even neater way of saying it, There's a theorem from junior cycle which says that the exterior angle is equal to the sum of the two interior angles of a triangle. X and x is 2x. So you can cut out this bit all together if you like. Okay. So now we've found this angle is 2x. And as I said, this triangle here is another isosceles, so if that's 2x, that must be 2x. Which means, again, that this angle here is 180 minus the two of them. So it's 2 and 2 is 4, 180 minus 4x. And the last piece of the jigsaw is, if we're looking for theta, again, this is all a straight line. If you take these two together, just these two together, 180 minus 4x plus x is 180 minus 3x altogether. That's 180 minus 3x on a straight line. Well, that must be 3x over there. And I've done that out down here. I mean, if you've got 180 minus 3x, and that's theta, well, if theta is 3x, minus 3x plus 3x cancels, and you just get 180. And there's your answer. Theta is 3x. And that's the end of part